Hello, my name is Noel, and my project is on the Intro to End Behaviors of Polynomials. So the main topic of, or the main idea of this topic is essentially being able to understand what an end behavior is, and being able to analyze a graph or a polynomial equation, and being able to pick out what the end behavior of said graph or equation is. So first we're going to start off with some key terms to kind of just understand the topic. So a polynomial is an expression consisting of several terms. An example of this would be x squared minus 64, as it has two different terms, x squared and negative 64. An end behavior would essentially be what describes the behavior of the function at either ends of the x-axis. Now, the x-axis doesn't have endpoints on either the left or the right side. What it means by this is that it will be able to pick the behavior towards essentially just negative infinity, or it just keeps going on to the left, or positive infinity, or it keeps going on to the right. Essentially, end behavior is the trend of the graph towards the left and the right ends of the x-axis, or just towards negative infinity and positive infinity. So how to write this, it would look like as x approaches, we'll use infinity for example, f of x, which would be the name of the function most likely, would equal, say, infinity. Now, it could either be as negative approaches, as x approaches negative infinity, f of x will approach infinity, or it will also approach negative infinity as x approaches negative infinity, or positive, and so on, basically. And a degree will essentially determine whether, or the type of end behavior that it is. So there are two different types, odd and even, and I will explain those right now with this with just a small example. So this is just the standard equation of a quadratic equation, or a quadratic equation in standard form. So this right here is the degree. So since it is even, it essentially means that the degree is, well, even. So since it is even, both the end behaviors, when they approach either negative or positive infinity, they will be the same, essentially. Meanwhile, if that number were to be like 3 or 5 or 7, that would make the degree odd. So that would make it to where it would be different. So as the left side, as you keep going left, it approaches negative infinity. If you keep going to the right, it will approach infinity. That's just an example, though. It could, of course, be the other way around. And this A will also dictate whether the line is positive or negative. So if A is greater than 0, the graph will essentially be positive. And if the graph is negative, or if A is less than 0, the graph will essentially be negative. So here, let's start with actual examples. So let's say we use the example x squared plus 13x plus 40. So what this would look like on a graph is that since this is a even degree, that means that both, as it approaches either the left or the right, it will be equal. And since there is a secret little 1 here, that means the graph will be positive. So the graph would probably look something like this. Of course, it's not exact, but it is relatively what the graph should look like. As you can see, as x approaches positive infinity, or f of x essentially approaches also positive infinity on the y-axis, and as x approaches negative infinity, it will approach positive infinity. So to write this would look like as x approaches positive infinity, f of x will approach also positive infinity. And then the same, you also have to write it again, as x approaches negative infinity this time, f of x will also approach infinity. Now, say this were to be a -1 instead, then the graph would probably look something more like this. Now, as you can see, since it is negative, that means that both of them will be going down this time. So as x approaches positive infinity, f of x will approach negative infinity, and as x approaches negative infinity, f of x will approach negative infinity. So that would just look like this. See, so as x approaches infinity, f of x approaches negative infinity, and as x approaches negative infinity, f of x will still approach negative infinity. So let's work with a different example this time. Here, let me delete all of this junk. Okay, so next example, x to the third plus 3x squared minus x minus 4. So again, look at the degree, and this time it tells us that it will be odd, meaning that whatever whatever x approaches, if it approaches the right, it's going to approach basically the exact opposite as the left. And since again there's a hidden 1 here, that means it will be positive. So when this is graphed out, it would probably look something like this. Again, this is not exact, it's just what a relative shape of the graph would look like. So as you can see, what makes this different is that instead of it curving down like a U, like how, it would be when it was quadratic, now it curves essentially the other way. So as it goes here, it will curve down, but then make a turn. And then you see that they're pointing in different directions. Basically, what this is saying is that as x approaches infinity, f of x will also approach infinity. However, as x approaches negative infinity, f of x will approach negative infinity. So to write this, it would look like as x approaches infinity, f of x approaches infinity also, positive infinity. However, as x approaches negative infinity, f of x will also approach negative infinity. Now, again, same concept. If you were to add a negative here, that would make this less than 1, meaning that the whole end behavior is going to be negative. So what that would look like is, let me draw it out. So it would essentially, again, not exact, just relative idea on what it would look like. As you can see, now it's kind of swaps. Rather than it approaching negative infinity, as x approaches negative infinity, it's now approaching positive infinity and vice versa. So what this would look like now is that as x approaches infinity, it's now also approaching negative infinity, but as x is approaching negative infinity, it's approaching positive infinity. So this even scales up with others. It's not just with 2 and 3 also. So let's use a of x to the 4th plus b of x to the 3rd plus c of x plus d. Again, degree, it's positive, or degree, it's even. A would assuming, or let's just assume that a would be greater than 1. Let's just assume that. So what this would look like is that it would look kinda, oh wait, nope, my bad. This would look kinda like a W, essentially. And again, same concept applies. Again, this is just a relative shape. As x approaches negative infinity, f of x approaches positive infinity, and as x approaches positive infinity, f of x approaches positive infinity. If you make it negative, you will flip it on its head and it will look like an M. Now, let's say, we're going to change it up a bit. So now, here, let me delete all this for a sec. Let's say a of x is equal to 5, or a of x, ax to the 5th, and then bx to the 4th, and then cx to the 3rd, and then d x to the second, and then f of x, and then g. So again, look at the degree here. The degree is 5, meaning it's odd, and we'll just assume that a is greater than 0. The relative idea that this would look like is like this. It curves once, then it curves back up, then it curves back down, and then it curves back up, kind of like that. And just like as if it were to be 3, it's the same, since this is an odd degree. As x approaches infinity, f of x will approach positive infinity, and as x approaches negative infinity, f of x will approach negative infinity. And you just write it out the same way that I did for the first two examples, essentially. And yeah, that's pretty much it. Thank you for listening to my presentation.